Good morning. Today's lecture is the first one that will actually start talking about classes of organic compounds. And we will start with the simplest class of organic compounds known as alkanes. Alkanes are hydrocarbons, which means that they are composed only of hydrogen and carbon. And alkanes, since they compose only of hydrogen and carbon, have no functional groups, and therefore their reactivity is relatively dull. On the other hand, alkanes are the most prevalent organic compounds on Earth because they exist in, they're the chief component actually of natural gas and oil, and because of the petrochemical industry, they're really the source of all the other organic compounds we study. From a philosophical perspective, alkanes, since they're the first class of compounds we'll study, will introduce us to many of the concepts that apply to all other organic compounds, and that's why they will devote an amount of attention that is a little bit disproportional to their reactivity to alkanes. Now, as I mentioned, alkanes are hydrocarbons, and among hydrocarbons there are several classes of hydrocarbons. The first one are alkanes, which have only single bonds. An example would be propane, CH3, CH2, CH3. Again, this is a condensed formula, but you should be able to expand this into a full structural form. Other hydrocarbon classes include alkenes, which have double bonds, alkynes, which have triple bonds, and aromatic hydrocarbons, which have this six-membered ring with three double bonds. Example of these classes could be, for example, propane, propene, propyne, or ethylbenzene. Now, among all hydrocarbons, only alkanes are the so-called saturated hydrocarbons. And they're called saturated because they have maximum number of attached hydrogens. All the three remaining classes are called unsaturated because they can add more hydrogen. As we mentioned earlier, some short alkanes have, well, all alkanes have names, but short alkanes have names which are particularly important because they will be relevant for other compounds as well. And so it's important once again that you memorize these names. So the shortest alkane is known as methane, and I'm writing it in this unusual formula, HCH2H, to highlight a similarity between this and higher alkanes. The second member of this class is ethane. Third one is propane. And then I will abbreviate the next ones, CH2 4 times butane, HCH2 5 times is pentane, CH2 6 times is hexane, and then C7 compound is heptane, C8 is octane, C9 is nonane, and C10 is decane. And the list goes on and on with undecane, dodecane, and so forth. But if you look at these first 10 compounds a little bit more generally, you will notice that the difference is between methane and ethane and between ethane and propane is in a sequential introduction of more and more CH2 groups, and a series of compounds which differs only in the addition of or removal of one CH2 group is known as homologous series. And the members of homologous series differ in number of CH2 groups. In other words, we would call ethane a homologue of propane. Or propane would be homologue of butane or so forth. Another important rule, as you can see from these couple of structures, is that we can represent a general structure of an alkane as CH2 n times, where n is the number of carbons, plus 2 more hydrogens, which ends up being a total of Cn, H, 2n, plus these 2 hydrogens, which really terminate the chain at both ends. And this is the general formula for alkanes. Now, this formula so far has applied only to straight chain alkanes, because I talked only about straight chain alkanes, but I would suggest that you try to convince yourself that this applies equally well to branched alkanes as well, by simply comparing these 3 isomers of pentane, all of which should have the general formula for pentane, which in this case would be C5H12. So I would urge you to try this at home and persuade yourself that it really is true.